Okay, so I guess the most important concept to talk about next is type. So if I just start off with a demo template, that will probably help explain what I'm going to do. So let's start by drawing a couple walls, and I'll draw a thin wall, and I'll draw a thick wall over here. And you and I both know that these are two different wall types, and that's how architects go and describe their walls. They say that this is a wall type A and this is wall type B, and they say that wall type A has a certain thickness and it's made out of this material and has this many layers in it, and wall type B has another thickness or another set of materials. And so if you say, what type is this wall, an architect will just point at their wall type schedule and they'll say it's this type of wall or that type of wall. And what they're really referring to is the construction type or the construction buildup of that wall. But then if you ask the question of a different type of objects, for example, if you say, what type is this column or what type is this beam? So let's go and draw a beam here. That beam is pretty low down. You might describe the type of the beam using its cross-sectional profile instead. You know, this is a certain I-beam with a certain dimension. And so I guess what I'm trying to communicate here is that when we say type, what type of object is this? It really depends on the object you're referring to, because for a wall it's different than a beam, for example. And if I said, what type of pump is this, or what type of door this is, that would mean something entirely different as well. You know, what type of furniture is this? Pumps and furniture would probably refer to a particular product that you're buying from a manufacturer, which has a model number. And that would be the type of pump or the type of furniture. And this concept is supported in IFC using what's known as types. So it's possible for this object, this wall, for example, to have a relationship, which you can see in the Object Information tab, to a type object. And you can see there's a sort of symmetry to this. A wall or IFC wall can be related to an IFC wall type. So if I draw multiple walls of the same type, you can see whichever one I click, that doesn't change because they're both they both share the same type of wall and they both have the same thickness of wall. Whereas if I click on this one, that one changes because it's a different type of wall. It's a different thickness.
Mm-hmm.
So I guess so one type can be shared across many occurrences, and that's the terminology that IFC uses. They have a type, and these are known as occurrences of a type. If you use Revit, this would be known as an instance of a type. And it doesn't really matter what software you use. Some software, they will not be as explicit about this. They won't specifically say types, but it's still inherent in how you document using it. So for example, if you're using civil software, you will still have pipe types or pit types. And what does it mean to have a type is different for different objects. Some objects, like for a wall, will define the thickness of the object, right? This wall can be a long wall or it can be a short wall, and they're still the same type as long as they have the same thickness and same materials. The moment they differ in thickness or materials, it's a different type. And that's not something that, and that is one of the ways that IFC supports you to have a type relationship. And we'll go into details about how that actually works a bit later. But it's important to know that there are different ways that types can influence their occurrences. Similarly with a slab, if I draw a slab over here, the thickness of the slab indicates, if I have multiple slabs with the same thickness, it usually indicates that it's the same type. And it is possible in IFC to have a slab type that will constrain all occurrences to have that same thickness. So I guess it is also possible to have things which have no type whatsoever. So for example, I can go and draw a new element, and this time let's create some sort of furniture maybe. And let's say this is a one-off chair or something like that, which looks like this. And this chair you can see, which looks like a box, has no associated type. And if you are doing a design where there are many occurrences of this chair which all come from the same manufacturer, which have to be procured, not having a type is bad practice, because that's not how you document it. The way you document it, the way you cost it, is by saying that you will have 10 of this particular type of chair, on this location of my building. So the existence of a type object will help, I guess, describe that relationship. And this is a big problem because many people have viewers and they look at their model like this, but invisible to them is basically a big list of object types. And it is possible to see that in Blender BIM. So if I open up the BIM tool, I can see the list of types that's possible here. So here are all my beams. I have all my columns over here. Let me hit refresh. These are all my column types. You can see it's denoted using a cross section. Here's all the type of furniture that I have. Let me just refresh that, and so on. So, and on the left here in the outliner, you can see a big pile of sort of, I guess, invisible. Let's just turn that one on again. Sort of these invisible windows and doors and so on that represent types.
And this is one of the. Let me ask you something. Two things actually. First, can you please move your microphone a little bit further away from your mouth? And the second one, could we look at these types as to Revit families? Can we make an analogy, like similar analogies to that?
Yeah, that's right. In fact, not just similar, it is exactly the same thing. So a Revit family type is identical to an IFC type.
Great. But it's not as straightforward to export a Revit family to an IFC type. Like usually we get these objects as occurrences, not necessarily as types with the proper information.
No, they will come out as types in IFC.
Yeah, okay. But don't we have to do any customization for that? They just come like that by default?
No, they just come out of the box. Yeah, there are bugs with how they come out, and some of those you could say are Revit bugs. Some of those you can say are complexities in how types are managed. So and this will come through an understanding of how types constrain their occurrences. So it's possible for a type to influence the data that an occurrence will have, because that's the point of a type, because they need to share information across these occurrences, right? The moment you have a wall of a different thickness, it's a different object. So one of the easiest way to explain that, so if I start a new object, a new model, and now let's create a new type, and it doesn't matter what it is, like it can be an actuator, call it ATO1, and we'll add a new custom tessellation for that. And you see, I haven't actually created any objects yet, any occurrences. I've just created one type in my type library, which I can see over there. And now I can place occurrences of it. But because my type itself has geometry associated with it, let me show the invisible type over there. That means that if I change the geometry of the type, let's say I shrink that, make that bigger, then it also will affect all of the occurrences. And that's one of the constraints that a type can have on the occurrences. And what that means is that if you mirror an object, it's technically that object is not identical anymore. So very often in other tools like Revit, if you mirror an object, it will actually invisibly create a new type that you don't see in tools like Revit, but it actually exists. And you'll only notice it when you finally put it out into IFC. And sometimes this is a good thing, and sometimes this is a bad thing. So for example, if you have some sort of furniture and you mirror it, technically that's not the same furniture anymore, right? Depending on the shape of the object. Whereas if you have a door and you mirror it, it would still be considered the same type of door because you just install the hinge on the other side, right? So I guess what I'm saying is that this is one of the constraints that you can have for a type and its occurrences, and that's one of the leading problems of bad exports, because people mirror objects, and that way, instead of having one, even on fully symmetric objects like this, if I mirrored this in another tool, I will then have two types, and that's obviously wrong. I was just being lazy using the mirror tool to position it in another room or something like that, right? I don't really want to create another type, because it's incorrect from the perspective of, let's say, facility management, or counting the number of beams of a particular type. Make sense?
Yes, makes perfect sense.
Yeah, so I guess before I sort of jumped ahead here talking about how the type geometry can constrain its occurrences. You can see it's absolutely identical. If I change one, they all have to change. In IFC, this is known as mapped representations, or mapped geometry. But before we get into the more complex ways geometry can be constrained, I'd like to bring it back to something a little bit simpler in terms of classification. So in our previous session, we talked about this two level of classification, this first level of the IFC class and the second level of predefined type. And you'll notice that this is defined like it is because my type object has a class of IFC actuator type and a predefined type of electric actuator. Now, if I click on an occurrence, you'll notice that there is no predefined type defined on my occurrence at all. And that's because it doesn't need to. It inherits that information from the type. So if I change this at a type level, I'll just manually edit it over here to anything over here. Then all of the occurrences similarly inherit that edited second level classification. And this is how things should be done. You should be able to, the ideal way is to classify your objects at the type level, and then all your occurrences will inherit it. And that goes the same for defining a user-defined type. So if I click on user-defined, and then I fill out something here, custom thing. Now you'll notice that this is again defined at the type level, and then it's inherited by all of the occurrences. So I have to check here. I believe if you want to go in, you can see if I go and edit this occurrence, I can't actually set the predefined type here, or the or set it to a user-defined object type. That's not allowed because it inherits it from the type. The only time you can do that is if you first set this to something that's not defined. Once it's not defined, then you'll be able to specify it at an occurrence level. So now I can say that this is a, let's say, a pneumatic actuator, and you can see this one is not defined, and then the occurrence has pneumatic actuator on it. This one doesn't have anything because it's now an occurrence-based thing, so I can say this one is user-defined, ASDF. Oops, sorry, did I pick not defined? User-defined. Oh, what have I done? Oh, sorry. That's better. See, it actually guarded against it because I didn't put it in the right field. Yeah, so now you can see I've overridden it at the object, at the occurrence level. But that is something I think we probably shouldn't be doing, or I really don't come across situations where that applies. The way I'd advise is to always apply your classifications at the type level. Make sense?
Yeah, definitely. It's nice that this feature is allowed, like in Bonsai. I didn't know about this, but yeah, definitely best to keep it simple.
Yeah. So I guess what's also, I just probably skimmed through it, but it is important to note that there are two fields here. There's this field. Actually, I'll go to this one. It's probably easier to explain. You can see that the moment I pick user defined, I then fill out a value in this field. And it's not immediately obvious to users that the point of this field is only to fill out information if you select user defined over there. That's really something that's not clear to any user, I feel, until you read the IFC documentation. And if you see any information in here and this is not set to user defined, your IFC is invalid. And hopefully you can report a bug to your vendor. And that's pretty important because it's a bit confusing in IFC. Why, just because I selected this, then I need to fill out another field somewhere else? And that's just the way how computers work, because they have two different data types, right? One is an input field and one is a drop-down selection. And I guess in the future, we might look at ways to enhance the usability of that. So at least maybe we'll reorder this so that they show next to one another. Or maybe it only pops up, once you pick user defined, but that's the way it is currently. And just a FYI. And so this is also a big issue because in tools like Revit, for example, and again, I bring this up because everybody uses it. A lot of people use it. If you want to set something user defined, there's nowhere to do it in Revit out of the box. You have to add a shared parameter to add that this IFC object type, or better yet, IFC element type over here manually. If you're using a different tool like Tekla or ArchiCAD, you won't have that problem. But just FYI, if you are using Revit, it's actually not so obvious how to even create user-defined types. It's totally hidden from you, and you need to do a lot of custom work to do it. So yeah, these two are interrelated. And I guess another confusing aspect is that at an occurrence level, you can see one is called object type, predefined type, and at a type level, it's called element type, predefined type. So in my opinion, this is just some annoying technical detail. And really the only way you should talk about it is just what's your predefined type? And then just if somebody fills it out in another location, that's fine. And that's just some computer detail. But the intention is for the predefined type to be either, pneumatic actuator or ASDF, and that's it. You don't need to go into the detail of whether it's stored here or there or wherever, or overridden or inherited. It doesn't matter. And that's important for writing IDSs, that you should never write an IDS and say, this applies to elements where you've specifically filled out the object type field. Nah, don't do any of that. Just say applies to pneumatic actuators, done. Cool, that's it.
Are there, what do you know from your experience? Are there any tools which are handling better than others when it comes to types? From your experience, from what you heard so far?
Yeah, look, I mean, Revit, you get it out of the box, but the classification is pretty broken. Tekla does it pretty well. Much better, I'd say. ArchiCAD is a bit interesting because many people don't realize how to manipulate types in ArchiCAD. But once you do realize it, it's actually quite a pleasant experience. Yeah, I don't really know what to say, but this is one of the most important features in any IFC model. And the crazy thing is that it's invisible in most IFC viewers. It's the most critical information, I'd say.
Yeah. Well, that's good. It's good at least that we have Bonsai where we can see these things. So that's awesome. Yeah. Thanks to you. Right. We can settle for this time, Dion. Thank you so much. Next time we can continue with something else, with what you think is like, do you maybe you can tell me right now, what do you think it could be natural to continue to go on with next time?
Probably continue on types, but show how there are property sets and inheritance and overrides, and then start moving into geometry.
Okay, cool. Thank you very much then. Have a great day and stay in touch.
Cool. Have a good one.